Have you ever wondered what happens when a star, many times larger than our sun, dies? Enter the supernova, a cosmic spectacle that signals the end of a star's life. These celestial fireworks are among the most potent events in the universe, unleashing a colossal burst of energy that can outshine an entire galaxy. A supernova's formation is a fascinating process, a stellar swan song that leaves a lasting imprint on the cosmos. So, strap in and prepare to embark on a fascinating journey to understand the formation of a supernova. To comprehend the death of a star, we must first understand its life. Stars are born from the collapse of vast clouds of gas and dust in space. These celestial nurseries, known as nebulae, are where the magic begins. Under the intense pressure and heat of this collapse, the atoms within these clouds start to fuse together, a process known as nuclear fusion. This process is the beating heart of a star, producing the energy that makes it shine bright. But nuclear fusion does more than just power a star. It's also a cosmic forge, creating heavier elements from lighter ones like hydrogen and helium. This process gives us everything from the carbon in our bodies to the gold in our jewelry. The life of a star is a balancing act, maintaining a delicate equilibrium between the inward pull of gravity and the outward push of energy from nuclear fusion. But what happens when the balance tips? A star remains stable as long as there's a balance between gravitational pull and nuclear fusion. But what happens when the fuel runs out? Picture this: a star, like our own sun, is a cosmic powerhouse, generating energy through the process of nuclear fusion. Hydrogen atoms collide and merge, forming helium. This process releases incredible amounts of energy, creating a force that pushes outward. This outward pressure is what keeps the star puffed up, countering the inward pull of gravity. But stars are not infinite. They can't keep this up forever. Eventually, they start running low on hydrogen fuel. As the hydrogen supply dwindles, the fusion process slows down. This diminishes the outward pressure that was keeping the star's own gravity at bay. Now, we arrive at a crucial juncture. The delicate balance that sustained the star gets disrupted. The gravitational pull starts to gain the upper hand. This imbalance between the outward pressure and the inward pull of its own gravity causes the star to struggle with its own weight. The star starts to shrink, to collapse under its own gravity. But this collapse isn't a gentle surrender. No, it's more like a cosmic implosion. The core of the star shrinks, but the outer layers don't get the memo in time. They continue to fall inward, speeding up, heating up, and setting the stage for an incredible spectacle. And thus begins the star's journey towards its dramatic demise. As the star collapses, it sets the stage for a cosmic spectacle, the birth of a supernova. The star, having lived a vibrant life, now finds itself in the throes of a dramatic change. Its core, once standing firm against the immense gravitational pull, can no longer sustain its stand. The star's core begins to collapse under its own weight. This collapse is not a slow, gradual process, but rather an incredibly rapid one, happening in less than a second. During this collapse, the core reaches astronomical temperatures, sparking a nuclear reaction that is unlike anything we can comprehend on Earth. The pressure and heat are so immense that the very atoms of the star's core are crushed together, forming a dense ball of neutrons. This neutron core is incredibly compact and incredibly dense. Imagine, if you will, the mass of our sun, a celestial body so large it could fit over 1 million Earths, compressed into a sphere with a diameter of just about 20 kilometers. But the story doesn't end here. The outer layers of the star, which were not part of this core collapse, get a shockwave. This shockwave, traveling at a significant fraction of the speed of light, propels these layers into space. The star, once a contained, organized structure, is now an expanding cloud of stellar material. And what a sight it is! This ejection of the star's outer layers results in a brilliant display of light. For a few weeks, this single dying star can outshine an entire galaxy. This is the moment we've all been waiting for, the birth of a supernova. In this spectacular celestial event, elements heavier than iron are also synthesized and then scattered across the universe. These elements, the gold in your jewelry, the uranium in our nuclear reactors, owe their existence to these dying stars. The supernova, a cosmic fireworks display, is now born. This grand spectacle, a testament to the life and death of stars, paints a vibrant picture of the universe's story. The supernova may be gone, but it leaves behind a rich legacy. After a star has exploded in a supernova, what remains is no less fascinating. The core of the star, once a fiery furnace of nuclear fusion, is now a dense husk known as a neutron star. These neutron stars are some of the densest objects in the universe, with a single teaspoon of neutron star matter weighing a staggering 1 billion tons. But the story doesn't end there. In some cases, if the original star was massive enough, even a neutron star cannot withstand the force of gravity. The core implodes, giving birth to a black hole, an object so dense that not even light can escape its gravitational pull. The supernova also leaves behind a cosmic potpourri of heavier elements. It's here in these spectacularly violent events that elements like gold, platinum, and uranium are forged. Every atom of these elements in existence was created in the heart of a dying star and scattered across the universe in the star's explosive death throes. And then there's the supernova remnant, a beautiful nebula of gas and dust, glowing with the heat of the explosion and the radiation from the neutron star or black hole at its center. These remnants can last for thousands of years, a lasting tribute to the star's life and death. Even in death, stars contribute to the cosmic cycle of creation and destruction. Now that we understand the dramatic life cycle of a star, how can you witness a supernova? Well, observing a supernova is no small feat. They're elusive, fleeting, and require a certain degree of luck and timing. But with a little know-how, you can increase your chances of catching this cosmic spectacle. First things first, you'll need a telescope. It doesn't have to be the most advanced model on the market, but it should be powerful enough to provide a clear view of distant celestial bodies. Remember, a supernova is an exploding star. It's a violent event happening light years away, so you'll need a bit of magnification to see it. Now, where to look? Supernovas, unfortunately, don't run on a schedule. They can happen anywhere, at any time, but they're most often spotted in other galaxies. So, if you're scanning the night sky, you'll want to point your telescope towards galaxies other than our own Milky Way. Next, let's talk about conditions. You might have the right equipment and know where to look, but if your sky is polluted with light or cloud cover, you'll have a hard time spotting anything, let alone a supernova. The best conditions for stargazing are dark, clear skies, far away from city lights. High altitudes can also be beneficial, as they reduce the amount of atmosphere you're peering through. Finally, patience is key. Supernovas are rare events. In fact, astronomers estimate that a supernova occurs in a galaxy like the Milky Way once every 50 to 100 years. And even then, many of these events are hidden from our view by dust and other celestial bodies. So, while it's not impossible to observe a supernova, it's certainly not an everyday occurrence. But don't let that discourage you. The rarity of these events is part of what makes them so exciting. Every time you gaze up at the night sky, you're participating in a cosmic lottery. And who knows, maybe tonight is your lucky night. Even though supernovas are rare to observe, the possibility of witnessing such a cosmic spectacle makes the night sky all the more exciting. We've taken a cosmic journey from the birth to the explosive death of a star. We've seen how a star's life begins in a dense cloud of gas and dust, and how over billions of years it grows, burning through its nuclear fuel. We've unraveled the mystery of the imbalance, that crucial point when a star's fuel runs out and gravity takes over, causing the star to implode. It's a cataclysmic event, a cosmological marvel that results in the birth of a supernova, a stellar explosion of such magnitude it can outshine entire galaxies. We've seen how the remnants of this explosion, the supernova remnants, can form beautiful nebulae, painting the cosmos with a vibrant palette of colors and giving rise to new stars, continuing the cycle of stellar life and death. We've also learned how to observe these spectacular supernovae. With the right tools and a little bit of luck, anyone can witness this astonishing display of cosmic power. From the birth of a star to its spectacular end, each step is a testament to the incredible forces at work in our universe. The next time you gaze up at the night sky, remember the incredible cosmic journey each star may undertake, culminating in the spectacular supernova.